haven't done much of a review of related rates, so I thought I would take a look at a few of those. Typically, related rates problems, they're not going to give you any kind of function or anything like that, but they're going to give you some kind of relationship. And the big thing here is you need to look for words that suggest that are talking about rates. So if you see the word rate, remember, rate is a derivative. You might see rate of change. You might see derivative, instantaneous rate. Just remember also that an increase or a decrease is a rate of change, and that means it's a derivative. So I notice here I see that the area is increasing, okay? And then they talk about its increase in comparison to how fast the radius is increasing. So if I see some kind of increase or decrease between different variables and they're not giving me any kind of function, I'm thinking probably a related rates problem. So notice they're talking about area in terms of radius. So I thought, well, let's start out with the equation area equals pi r squared, and let's see where we can go from there. So you'll notice there are no rates in that equation. So the whole concept of related rates is you can take the derivative, usually with respect to time, and you get a new equation that has rates in it. So when they're talking about an area changing, they're talking about dA dt, the rate of change of the area as time changes. When they're talking about the radius changing, that's the rate of change of the radius as time changes. That's dr dt. Okay, so anyway, we've got our function. Area is equal to pi r squared. Derivative of a with respect to t, of course, is dA dt. And over here, you only have one variable on the right-hand side, so you can apply the power rule there. You're going to get 2 pi r times the derivative of the inside function with respect to t. So that's times dr dt. Now, this one's kind of interesting because they don't actually give you values here. They just say that the area is increasing twice as fast as the radius. So you could just say, well, let's say the area is increasing at 2 square units per second when the radius is changing at 1. Okay, or you could do like 4 and 2, or you could do 10 and 5, doesn't matter. But anyway, I picked one rate to be twice as big as the other one. We need to figure out what the radius would be here. And so if you solve that equation, you end up finding out that the radius is equal to divide both sides by 2, divide by pi, and you end up with 1 over pi as the radius in this particular problem. And that, of course, is choice C. So that's a pretty simple one. The weird aspect being that they never actually gave you any areas or radiuses or even any rates. They just told you one was twice as big as the other. And by the way, the real way to do this, the formal way to do this, would have been to say that this value here is 2x and this value over here is x. So one rate is twice as big as the other. And then when you divide both sides by x, it would cancel the x and you get the same answer. So the point is it doesn't matter what rates you put in. As long as the area rate is twice as big as the radius rate, you're going to get the correct answer.